belaying for rescue purposes in a practical sense. Let's just dumb it down and then we'll go into more in-depth stuff. So in rescue, by default, typically we'll do something we call an independent belay, or independent team belay to be more exact, where independent means it's a separate line altogether, and team being the load is not tending or operating the belay. So the belay is located at the anchors on a separate line, and you could argue that two tension rope system, I would consider that to be an independent team belay too, if it's being rigged appropriately. So all these devices will work. So there are four categories. Independent team belay is what we do in rescue most often. There's independent self-belay over here. If I was rappelling, so independent self-belay, independent being on a separate line, self being I have something that will arrest my fall, in this case an ASAP. So, and it's attached to me, to the load that's actually moving. So it's independent, separate rope, self-belay. The device is at the load. So this is like when you hear rope access, that's independent self-belay. Rope rescue, you kind of automatically think independent team belay. So that's two of four categories. The other ones are conditional belays. Conditional belays being it's under the condition that there's only one rope. So it's a single rope technique. So there is no separate rope as a backup. And so if we were doing just like recreational climbing and I was rappelling down, I didn't have anything and I'm hanging it out big time, a single rope, and I have no backup here. So if I lose control of my brake hand, I'm gone. And so a conditional team belay would be that, okay, it's one rope, it's conditional. Somebody else is gonna provide the backup in case I lose control. And so this is your classic fireman's belay. So down below, somebody is holding onto this line loosely. And if I panic or I let go and it starts to go, they can actually pull down and provide that stopping powered by the bend right there. And that would be a fireman's belay. So conditional team belay is fireman's belay. Let's go to conditional self-belay. Your aperture belay device, in a recreational sense, I extend out my device so I can make room for they call it a third hand, basically a rope grab. So we have our VT press secure. And so if I lose control and I go hands free, my third hand grabs it and it's belaying me. It's preventing me from falling. So this would be your conditional self-belay. You can also do this with an ID or any auto-locking device. If you're not using any separate line, it's a conditional self-belay because the device itself will auto-lock if you let go or if you panic, the ID and some other things. Other devices, they have that anti-panic feature, so that would be a conditional self-belay. So those are the four categories. The big hoopla and the big controversy, the arguments, the debates over years and decades in rope rescue or any kind of rope application for people that geek out on this stuff. It all goes back to the belay, the what if. How do we stop people or arrest people from falling? We want to stop people from falling or arrest the fall, but in rescue, we want to do so in the most minimal distance with the least amount of force. But it's a negative. You can't have it your cake and eat it too. So you have to kind of play this balance game. So force equals mass times acceleration. We can definitely try to limit the mass by reducing the number of people in our load. So if we don't have to have rescuers tend like a patient, then we don't need to. So we can adjust that. The faster, the quicker, like if we want to stop instantaneously, unfortunately that amplifies our impact forces or the arrest forces. So you have to have this, we have to strike this balance. So yeah, you could do a bungee line and like slowly elongate. You're increasing the distance and you're spreading out that impact force over a longer distance, but you're still moving, and we don't want that to happen in rescue. We want to minimize the deceleration distance of the impact force as well as minimizing the impact force. And it's either one or the other. There's this whole confusion about safety factors and what that means, static system safety factors, 15 to 1, 10 to 1, and then translating that to a dynamic safety factor. So for simplicity's sake, let's just throw out the 15 to 1 static safety factor altogether. Just forget you ever heard that. Let's talk about where all this kind of sort of originates from in a nutshell. In the 1980s in Canada, they did some drop testing and they came to the conclusion based on certain masses in a worst case scenario that like a 2-person load falling and like a 0.33 fall factor, or 1 meter drop with 3 meters of rope available is a 0.33 fall factor. And they recorded the max impact forces. On average, it was 12 kilonewtons. Okay, so what? Going back to just safety factors in general, and taking one step back, well, let's look at things we use to move objects and equipment, like chain hoists, wire come-alongs, that sort of thing. We're typically lifting heavy equipment, and in rescue, we lift that off of somebody who's trapped, and there is no backup or belay for those devices. The backup is a stabilization system, and the most basic being cribbing. So we crib as we lift to capture, and should the chain hoist fail, the load rests on the cribbing and doesn't smash our patient. But for rope, our subjects are on the rope. So if there's a failure, our systems need to be able to absorb impact forces, and it's not the same thing as when you're lifting equipment. Usually a lot of the equipment stuff has things called working load limits, formerly known as safe working loads, and they're usually on a 4-to-1 or 5-to-1 safety factor. Sometimes, for example, like Paratech struts, like they even list like a 2-to-1 threshold in there. Okay, so what? Well, I like to kind of think of like the working load for equipment, material handling equipment, as the same thing as a dynamic safety factor for like the life safety rope. The 10-to-1 is a static safety factor because we're trying to anticipate for the what if of a dynamic impact force. Impact forces shoot up exponentially once motion occurs, acceleration due to gravity. And so if you look at the testing they did in the 80s, and it was 12 kilonewtons was the average impact force for, what was it, 2-person rescue load, 2 kilonewtons, 200 kilograms. They said, okay, general engineering concepts, 1.5 to 1 to 2 to 1 safety factor for a worst case. So they did the worst case scenario, and the worst case impact forces on average were 12 kilonewtons. So they said, okay, well, if we multiply 12 by 1.5 or 2, what does that give us? It's about 18 kilonewtons to 24, 18 to 24 range. And so the whole 20 kilonewton, 22 kilonewton, those numbers should probably ring a bell for most rescue practitioners. 22 kilonewtons commonly is something you'll see stamped on a carabiner for minimum braking strength. 22 kilonewtons is also the threshold for all your minimum braking strength for components for OSHA and ANSI, ASSP standards. Yeah, 10-to-1 safety factor, what does that mean? If you take 20 kilonewtons and a 10-to-1 safety factor on that is 2 kilonewtons, that's your classic 2-person rescue load or 450 pound force. So just, that's where it all comes from. So fast forwarding to modern time, in America, they had kind of took that belay testing from the British Columbia Council for Technical Rescue, now known as Emergency Management British Columbia. It was called the Belay Competency Drop Test. ASTM standards, I can't rattle off the number, but it's F2 something something. They have a specific criteria, testing criteria for how they go about testing devices, and they have 3 different options for masses, and then they do all this like, okay, it has to drop from a certain height in these conditions, environmental conditions, et cetera, et cetera. By the way, they also use a bowline knot to actually test for belay devices. So if you're ever questioning a bowline knot, well, all the devices you use for belay rated devices are tested using a bowline knot. Gee. So NFPA took the ASTM standards for the belay drop test, and they incorporated performance criteria with that, because the ASTM doesn't indicate any performance criteria. NFPA came in and specifically cited that in their 1983 standards. So they used that ASTM test, and they use it in 2 masses, one for technical use and one for general use. So, and it doesn't really matter, like, all that is just a stamp. So if they say, oh, the mass we use for general use is 617 pounds, and the mass we use for technical use is 300 pounds, whatever. The requirements are they have to arrest the fall with no more than 1 meter of slip through the device and no more than 15 kilonewtons of impact force, and not break anything. That's the performance requirement for NFPA. And then devices that they test that meet that standard, they'll stamp on the back of these devices and say that they're NFPA, meets NFPA belay. This one, belay general use for that diameter rope. Same thing here. Belay device, technical use for 11 millimeter rope. Same thing here. Let's see, NFPA, meets NFPA for belay device, technical use. Okay, so, I mean, it's good to have some sort of standard, but also they're selling a product to organizations that abide by NFPA standards, and NFPA is not law, but it carries the weight of law. So you could argue like, oh, you want to buy a device that has that stamp. But do we always use them? No, of course not. All right, let's go from the Maestro on down. Okay, the Maestro, NFPA rated, great device. The MPD, NFPA rated, blade device, great device. My personal clutch, I like this one because it swivels. So the clutch, also NFPA rated blade device. The Petzl ID, NFPA rated blade device. As well as the rig, also an NFPA rated belay device, as well as the ISC D4. The Grillon lanyards, it's not. Now, will it arrest a fall? Maybe, I don't know. I haven't seen the testing on this. But you can descend on it. The Madrock Safeguard, there's some controversy on this. I love this thing as a work positioning lanyard and a fall restraint lanyard, or rappelling, so long as you're doing those activities responsibly and you eliminate any possibility that you're gonna fall onto it. Like if you're rappelling over an edge and you fall onto it, like a sharp edge, and you have bad technique, or you're using this and you think you're using it as a fall restraint, but you're really not, and you actually fall on it and go over the edge, this could break 8mm rope. But you can rappel on it, you can use it for work positioning, and as a fall restraint lanyard, even though some people would say don't do that, I'm a huge fan of it, as long as it's just don't shock force your safeguard and you'll be fine. Okay, ASAPs. Not a rated belay device for NFPA, but we use them all the time. And the reason why this is not a rated belay device is because it has stitching inside here that will rip, I think anywhere between 650 to 780 pounds, it'll start to tear and elongate and stretch, and that will dissipate your forces, but it will greatly increase your deceleration distance. And so if you look at the standards, the belay standards, the drop test standards, no more than 1 meter of slip. The stitching in here exceeds that, potentially. There are two different types of ASAPs here. One's ASAP 40, one's an ASAP Access. This I can belay with. Granted, it may elongate more than the 1 meter, hence it's not the rated device, but it does work. And according to Petzl, you can put a 2-person load on this. I don't know what kilograms they specified it at, and they did a drop test and it did not break the rope. However, the ASAP 40 does break the rope. So you can't use this for a 2-person load, but you can use the ASAP Sorber Access for a 2-person load. And so this is what we use in fire rescue quite often. Yeah, whether it's lock or just the standard, doesn't really matter. The VT Prusik, 6/1 or max over 1, when you pair 11mm rope with 8mm VT Prusik. It's not a rated belay device, but it passes that standard, but there's no stamp on it. This is great, it works. The traditional tandem Prusik belay, also these Prusik don't, it's not a device that you can like stamp, oh, NFPA passed, but it works. It's time tested, it works. So the ASAP Access, the VT max over 1, and the tandem Prusik belays don't have that braided belay device capacity, but we use them all the time anyway, and they work. Don't ever use a rescue center for a belay device. It's a great rope grab, at a minimum to at least, 5 kilonewtons, 1,125 pounds, somewhere in there, but it could hold more than that, maybe less, depending on the rope, on the conditions, but it's not meant to absorb impact forces. So never use this as a belay device. People were always scared about using these because they're thinking, oh, the mechanical cam is gonna sever the rope. Yeah, if you're using it incorrectly, as in you're introducing a shock force on these, then yes, but otherwise it's a great tool. I love this better than a Prusik rope grab because it's easier to release. I can do a lot of cool things with this. All right, so let's look at the Absorbica lanyard. I am a worker that's working at heights. I'm standing on a platform, and so like what's preventing me from falling are just me on the ground. That's my primary working line basically, and I have to have some sort of backup. And this is my backup. It's on my dorsal, and if I should fall, this is my belay or my fall arrest or backup. They all mean the same thing. There's a common misconception in the recreational world, and I think it stems from the fact that rock climbers' like primary means of support from falling are their hands, or is their body on the face of the wall. And if they have a dynamic rope and somebody's belaying them, yes, they're actively belaying. But the second they fall or let go, or even lean back and say, like, hold me, the belay is in effect. The belay has successfully worked. And you say, okay, yeah, you're on the belay. Okay, now lower me to the ground. Okay, well, you're no longer on a belay, you're on a working line at that point. And so there's a subtle but very distinct change, or that conceptual idea sometimes doesn't transfer over to rescue, where it's really important. Because I see people trying to rescue people on a single line and say, yeah, you're on belay. No, you're on a single line, there's no belay. So somebody's working at height, this is their belay. It's an independent self-belay because It's a separate system from their primary system, which is just their balance walking on a platform, and itself because it's attached to them, to the load. Granted, once they fall, they can't rescue themselves, but it still is an independent self-belay. All right, going back to the ASAP 40, also I can use this attached to myself, and this would be an independent self-belay. So in summary, belaying to arrest a fall, to stop an unintentional fall, to secure someone, to prevent an unanticipated fall. That's what belay is. Same thing as fall arrest, same thing as a backup. Those terms are interchangeable depending on what kind of environment or industry you're in. People would say that this 10-to-1 safety factor is so big, it's just this lofty. Why do they have to have this big safety factor in rope rescue? It's really not. That translates to a worst case scenario of maybe 1.5 to 2-to-1 safety factor, dynamic safety factor. So there's a difference. We can plan for a static system safety factor. We can't really plan as well for a dynamic factor. But really what's important is that worst case potential fall and how much force we have to arrest and save a life or keep from screwing up. And that's the dynamic safety factor, 1.5 to 2. Now, does that mean that can we operate systems at below 10-to-1 safety factor? Absolutely. Case in point, high lines. On a track line, I can probably tension that thing up well beyond a 10-to-1 safety factor because the track line and a high line is not a belay. It's not going to ever absorb any kind of impact forces. And granted, you could say that, well, if you have kind of jerky control line operators, there could be some oscillations. So yeah, maybe a little bit of oscillation in there, but it's not a catastrophic failure. Absorb an impact force on a track line. So I can tension track lines probably to 4-to-1, 5-to-1 on that system. The control lines on a high line, I would absolutely want to build those with the 10-to-1 static safety factor in mind because those control lines would have to absorb the impact force from a failing track line. Going to just standard high angle rope rescue, main and a belay. The main line system, I can operate at safety factors less than 10-to-1 if I want to. I just need to make sure that my belay line is built to those 10-to-1 safety factors for that worst case scenario. And then 2-tension rope system, by default, inherently, your forces aren't going to be that high. That's a whole nother story.